I get the green light from YouTube, we should be good to go. All right. Prepping is prepping. And cool. Awesome. So we should be live right now, which is great. Welcome, welcome, welcome. And let's just get into it. Let's just jump in, right? We're here to be full stack devs. That's the purpose. So we're gonna make this happen. Like I mentioned, y'all, my name's Cam. I am going to walk y'all through everything that I believe that you need to know to be a full stack engineer in today's times. So to do that, the first thing that I want to make sure we get accomplished is that we can understand what does the web and web development mean, right? We hear this all the time. You're going to hear this a lot, especially if you're somebody that's curious about being a front end engineer, back end engineer, full stack engineer. What do those terms mean, right? But to do that, we have to kind of jump back a little bit to talk about web development in general. And maybe you've heard of web development. Drop in the chat if you have. Like, have you heard of the term web development before? And if so, right, what do you normally think that means, right? When you hear somebody say web development, what comes to mind to you as to what that really means? And yeah, we're going to demystify that and hopefully get some clarity on that together right now. Cool, 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 cool. Awesome. So to start, we have to talk about a couple things, right? The first thing is we need a background to what are we referring to with all of this content when it comes to web development, right? We have to understand that the web is not the internet. I think that's a big point that sometimes we don't really learn about often. And so hopefully today's lesson will help clarify that a bit. We have to talk about how does the web work, right? Once we demystify the web and the internet, we got to talk about, well, how does it actually work? Then we'll talk about something called HTTP, the Hypertext Transfer Protocol. We'll talk about the difference between client-side programming versus server-side programming. And we'll talk a little bit more about, wrap that all together with a modern web development breakdown, right? So what does that mean to be in web development? And that is where we'll answer the term, what does it really mean to be a full stack engineer? So that's my goal, and we're going to make it happen right now. Just send me, just drop a thumbs up, send me a like, you know what I'm saying? Do some hearts, whatever you got to do, just to let me know that you're here, that you're present, and that you can hear me more than anything. And we're going to get it rocking right about now. Cool. Appreciate that. Appreciate that. Appreciate that. Dope. So, what is the difference between the web and the internet? Right? What is the difference between the web and the internet? I want everybody to take a couple seconds, just right quick, and type in the chat. What do you think is the difference between the web and the internet? Let's say let's say you're in CS class with somebody, or your little cousin comes up to you and they're like, "Yo, what's the difference between the web and the internet?" First of all, if my cousin came up to me and asked me that question, I'd be like, "Dang, you spending too much time on YouTube." But and, I still would try to answer this. So how would you answer this question? If somebody asks you, what is the difference between the web and the internet? How would you go about answering this particular question? And let me make sure I'm able to see those chat. I think it's a little tough because of the way that this thing is set up, but I see a lot of folks are in the chat. The web's an individual site where we can interact with specific items. The internet is what connects a bunch of websites together. Like the mitochondria is the powerhouse of the cell. I love that. The web would be the pages or the sites we use, while the internet is the larger system, maybe. Right? The web is a place to access the internet, while the internet is a place of interconnected hardware. Right? The web is a part of the internet. Wow, y'all really got it. Your cousin would be really set up for success if y'all were the ones answering that for them. And it's true, right? A lot of times, and I like to do this as an exercise. Just give me a thumbs up if you were like the difference between the web and the internet, huh? What? Is there a difference, right? Because if that was you, that was me, right? I was the same way before I really started getting into web development as a career and understanding that there was a difference. The internet is not the same thing as the web, and that's my big takeaway here. You probably can't remember a time before the internet. The internet itself was created many years ago through the Department of Defense, and really they, in a military context, were coming up with research initiatives to better communicate data using computers at the time, right? So the internet as a project has been in existence for a long time. Um, Now, what the internet is exactly what a lot of y'all were alluding to in the chat, right? The internet is a global network of computer networks that rely on a standard protocol to communicate. If you think about it, right, what does it mean to be in a network? Like if I was like, yo, like me and this person are in a network together, right? And not necessarily a technical network or a computer-based network, but just generally. Like, let's say I'm networking with somebody, I'm trying to get a job, I'm networking with recruiters, right? We hear those terms a lot. But realistically, if you think about what a network between people is, right, is very similar to what a network of computers are as well, right? A network really is a group of connected parties, right? Or in the case of people, connected parties, but in the case of computers, connected computers, right? And for those computers to be connected, what they need is a way to communicate with each other. Just like if you were to say, I'm in a network with somebody else, that would mean that I have a way to communicate with that person. Like, give me a thumbs up if you kind of understand what I'm saying, right? Like I can't say that I'm in a network with somebody if me and that person don't actually have any way of communicating with one another. Just like a computer can't be in the same network with another computer if there's no way for that computer to connect to communicate with the other computer. Now, communication for us as people is way more simple than it is for a computer, right? Well, let me not even say that because you know what I mean. Like it'd be hard to communicate as people too, but for computers, it's a little bit different, right? We communicate within a computer context. We communicate via data transfer, right? And the data transfer process happens over a networking layer of internet communication. Now, anybody interested in that, going deep into that understanding of the communication between two computers in a network, would be very interested in network engineering, for instance, right? And network infrastructure and IT and these types of fields that really study the network layers of the internet that allow for these computers to connect and communicate and send data and handshake and all of these things. But for those of us who are not necessarily as focused on getting as deep into the network engineering or the layers of the internet for lack of better words, the one thing that you need to know is that the internet follows a standard protocol for communication across computers, and that protocol is called TCP over IP. Again, there's other protocols, and there are many more things to say about like how that protocol is used, but just know that computers in a network utilize a shared protocol to communicate, and that protocol then allows them to connect and share and transfer data in many different forms. Some of those forms include things like the FTP process, which is the file transfer protocol, which is a way for computers on the internet to send transfer files to one another, right? The Another means of communication is SSH, right, where you can securely, or secure shell, where you're able to connect virtually into another machine by way of using the internet. And then another one is HTTP, which we're going to talk a little bit more about in a few minutes. But HTTP just is a way for us to communicate with other computers over the internet. Drop in the chat if you're familiar with any of these protocols, FTP or SSH or even HTTP. Drop it in the chat. Would love to know if y'all have any familiarity with any of those particular protocols. And if you have, talk about how you use it. Like, what did you use FTP to do, or what did you use SSH to do? Where did you hear about HTTP? But we're going to get into HTTP in a little bit. Um, Another important thing to keep in mind when we talk about the internet, right? So the internet is this big network of computer networks. So what that means is we just define what a network is, right? For a computer group, right? A computer group would have a way for them to connect to each other and share data. Sometimes that's through direct connection via Ethernet type things, or it could be over the internet. Um, and the other thing to note is that the internet is not just one network, it is a network made up of smaller networks. And that's what makes it such a massive and really amazing part of our lives is that every computer network, right? If you're at home right now and you have Wi-Fi on your computer, your iPad, your watch, your toaster, because you a smart home having person, is connected to your Wi-Fi, right? All of those devices are using your local area network to connect and communicate with one another. That is your personal computer network, right? Or your local area network. But the internet then allows for that same local area network that you have with Spectrum or Comcast or AT&T, whoever is your internet provider, right? To then connect via the internet to my local area network where I'm using all my devices right now in my home and sending data through the internet for you to connect to as well, right? That is only made possible by the fact that the internet is the network of all of these networks and hosts all of these things for us to connect and communicate. We can access the internet in a number of different ways. Just want to highlight this, right? You can connect to the internet via your cell phone. You can connect to the internet via satellite, dial-up, or Wi-Fi, right? There's all these different ways to connect to the internet. But when we connect, what we're connecting to is this large network of different computer networks that we can share data to in different ways. So long as that point makes sense to you, just give me a thumbs up. I just want to make sure that we're on the same page here. Cool, cool. You probably can't remember a time before the internet, right? It was created way beyond before our time. Awesome. So what then is the web, right? If the internet is this global network of networks, then what is the web? Because sometimes we hear about these things and we use the terms interchangeably. And like I said, like me, I used to use the internet and the web, and I thought I was saying the same thing. I'd be like, oh, the internet is crazy. I'm on Instagram scrolling, I'm seeing some dog pictures, and then scroll to some other drawing. And I'm like, this is crazy. And I'm like, okay, that's enough internet for the day, right? Some of y'all know what I'm talking about, right? We definitely be using the word internet to describe things that are happening on social media or when we're browsing, right? But the reality is that the internet and the web are not synonymous things, right? We just define what the internet is. It's this very it's this global network of networks that is made possible by way of hardware connecting us through software, right? And the web then is something different, right? The web is a specific way that we can transmit and receive data over the internet. And the web then is a means of using the internet protocol, the TCP over IP communication, and say, hey, I'm going to just create a layer on top of that for us to do something in a specific way, for us to send data in a specific way. So that the World Wide Web really was a project on how can we send and transmit data on the internet in a new way. And it was created by a researcher, similar to y'all, like somebody just, fascinated with technology and learning all of these things. And he was really curious about how could they improve a solution for information sharing for scientists at different research universities. The internet already existed. They knew that the internet was a thing, but Sir Tim Berners-Lee is his name. He was curious about, is there a better way to send this data to these other scientists in a more streamlined and efficient way than the current ways of using the internet protocols of the time. What he created was the web, the World Wide Web. And that was his project that he used the internet protocols and created a number of different tools that we still use today in order to send data over www, right? The World Wide Web. Two very specific resources that he created in order to allow us to do this are URLs and the hypertext transfer protocol, right? A URL is really known as a uniform resource locator, right? And that is, we're going to get into what does that mean, like where are we locating this resource, right? But the URL is a characteristic of the web, right? Other types of communication protocols built on top of the internet don't use URLs, for instance, right? So that is one of the things he created as a means of differentiating his his this project on the web from some of the other ways of communicating over time. The second thing that he created that was also very important, and it's not just these two things. There's a whole list of stuff that he created that is pretty vital to the modern web. But the second thing that is very important is he created a means of transferring data across computer to computer on the internet that we call the hypertext transfer protocol. With those two things, the ability to kind of locate resources on a machine and the ability to send that data from that one machine to another machine via the internet, Sir Tim Berners-Lee effectively created a new method for transmitting and receiving data over the internet. That solved his problem, which allowed for researchers to share information in more unique ways. Another resource he made that you might be like, well, hypertext transfer protocol kind of sounds familiar, right? Well, one third thing that I should probably add to this that he also created was HTML, right? Hypertext markup language, which allowed for them to not only locate the resources, not only send the resources via this transfer protocol, but he created a way of structuring what that information looked like and felt like. And that is what gave I don't even want to say gave birth because that's kind of a crazy metaphor, but that's what put him in a position to build this particular tool and resource that has revolutionized our life, right? I can't imagine a life without the web, much like I can't really imagine a life without the internet. Though sometimes because of bad service, I will be in places where I don't have the internet, right? But even then, right, like I said, we can still connect to the internet with our cell data. So it's kind of tough still to even imagine like daily life without all of the internet-based things that we do. On top of the internet being shut down, right? If the internet goes down, mad things go down, including the web, right? And if the web goes down, that doesn't necessarily mean that the internet's going down. That just means there's some issues in the ways of communicating between computer to computer over the internet. There might be other ways for us to connect, but the web itself is down. But the web is contingent upon the internet being up for it to exist, which is, I think, why we sometimes equate the two things, which is why sometimes we'll say the internet and when we really mean the web, right? Because we're not always interacting just on the bare metal of the internet. We're always kind of interacting via the web and the protocols that Sir Tim Berners-Lee and his team really devised for us. So this was mind blowing for me, y'all. You know what I'm saying? First of all, you don't really be learning tech history like this. You know? Not like this, like, oh, your boy Cam giving you tech history. But I mean, like, you don't really hear about how all of these things are created in a way that I think helps you make sense of all of the stuff that we're using technology to do. And I think that knowing that history is really important because all of the new innovations that we're talking about need these particular technologies to exist. They're being built on the backbones of all of these systems. So without understanding these things, it's kind of hard to know, well, how are we getting all of these engineering full stack and whatever jobs, right? Well, that's because we're using this protocol to send data every day and every second of every day, right? All the massive companies that y'all are trying to apply to, the Googles, the Facebooks, the Metas, you know what I'm saying? All of these companies that make money over our actions online, right? They're making those user interfaces and experiences on the web, right? We use Google online on the web, right? We use Meta and Facebook and its tools, Instagram, TikTok, all of these things. You know, every website we go to, we're using the web because that was built for us to then allow. That's what allows that infrastructure to exist for us to go to a site and then receive this information. If that's mind blowing to you as much as it is to me, drop something in the chat. You know what I mean? Send me a reaction, a like, or something. You know what I mean? I just think maybe I'm geeking out. Maybe I'm the only one, but I think that's really fascinating. And kind of interesting history that we don't always learn about. Cool. So the web doesn't equal the internet. That's really the gist of this story here. So knowing that, that puts us in a great position to ask one other question, which is how does the web work, right? Like I was just alluding to, we're able to go to a website like google.com and then something magically happens. And then we're on Google and now we're doing stuff on Google. We're typing in things and then we're seeing search results, or we're typing in a location and we're seeing a map pop up. If I'm going to Twitter, I'm going to Twitter and I'm typing something into the URL, to the browser, and then I'm seeing tweets, right? These types of experiences are happening via the web. But let's talk about, well, how does it really work, right? And this, my friends, is a very popular interview question for folks who are applying to jobs, thinking about being a full stack engineer, thinking about being a web developer. People will always ask you this question, like, talk to me about how the web works, right? And I'm going to simplify it in a very simple way. But again, there's a lot more depth to each of these points. Let's say I'm going to google.com, right? Everybody's familiar with Google, right? Google is a company, but Google has a website that is linked to the domain google.com, right? So when I say domain, I mean that thing we type in the URL bar of our computer to see information, right? Google.com, Twitter.com, Meta.com. Like those domains are linked, are representative of the companies that have purchased them. There's a whole history to that, right? And the .com boom and all of those things. But just know that they created these web domains, and web domains allowed for companies to have an address that was memorizable for the public, for us to say, hey, I'm going to go to google.com, right? And that allows for us to connect. So we know Google as google.com, but the first thing we normally do within the web context is we try to connect to that website using the domain. And how we do that is we type it into the search bar, and then when we press enter, these three things happen. First, that domain that we typed in, the address we typed in, is connected via our internet service provider to allow for us to find a particular server, and we'll break down what that means. Let's say a particular computer, right, that has information for that domain address. That particular computer is what we would call a server. And we use a domain name system service in order to basically say, how do I translate google.com to Google's server's IP address? An IP address is a sequence of numbers unique to each computer on the internet. The IP address to a particular server or a particular computer is a lot like your phone number is to you. Right? You have a particular phone number. If someone knows your phone number, they can hit you up, right? If someone knows your IP address, they can connect to your machine in specific ways based on the security parameters that you have set up to your address, right? The domain name system service is literally the thing that we use in order to say, hey, how do I get google.com's phone number? Right? Or IP address, right? So google.com, every website that we go to has a unique IP address associated with its domain. And our DNS server, which is provided to us via our internet service provider, your internet service provider is the Comcast, the Spectrum, the AT&T, the Verizon, right? Whichever service that you're using to get internet in your home, that, whatever service you use, you pay your bill to get Wi-Fi every month, that's your internet service provider, right? One of their jobs as your internet service provider is to connect you to a DNS server when you make requests online. And in using that server, it will return to your computer, whether that computer is your phone or your iPad or your PC or whatnot. It will return the IP address for whatever it was that you were looking for so that you can make a connection to that particular computer. It basically is like a big phone book, and it's like, okay, cool, here's the number you need for that particular computer. Go ahead and call it, and you make a connection. Your computer makes a connection to that other computer using that number, that IP address. And if the connection is accepted and successful, you'll get back something from the other computer you tried to connect to. Just like when you call somebody, right? Ring, 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 and then something picks up. Or, you get told, hey, this number can't be reached, or you find out you blocked. You know what I'm saying? It's the same process, but, personal versus actually happening in the computer. When we get back information from a server, typically one of the things that web servers are built to do, and one of the things that Google.com's particular web server is built to do, is return to us anyone who's making a request or making a call using the IP address. It returns to us some HTML, and that HTML is what we get back finally when we actually go to Google.com, right? You know how it refreshes and we're like, oh, wow, here's Google.com, right? Well, that is that in and of itself is the HTML that Google is giving to us to see. And we'll take a look at that in a second. I'll show that to y'all just so you're familiar with what I'm talking about. But this is the process, right? We use a domain name or whatever we're familiar with of a particular business or site, and we get connected to that particular site's IP address. If the site doesn't have a domain name, I need its IP address at least in order to make a connection. And you can refer to Google.com either as Google.com or with its IP address number, which is unique to that particular domain name. And once we establish a connection, then we get back some data from the other computer. So in our case, it would be like we made the connection, our internet service provider hooked us up, facilitated connection to Google. Then Google, in step 3, is the server in this context, and it sends back some data to us. To make this simpler, we have to kind of talk about the HTTP process, which really is where this language of server, client, and these things come up. So there clearly is a sequence of events that take place when I'm trying to go somewhere on my computer and get some information, right? So this process of transferring data between web domains and regular people looking for information is what we call the hypertext transfer protocol. Remember, I said this is one of the big things that Sir Tim Berners-Lee created in order to make the web, right? HTTP is really just about the cycle of requests and responses that happen between two computers trying to communicate using that method I just talked about of the IP address, sending data, etc. Right? So the HTTP protocol is comprised of 2 actors and 2 types of communications, right? The first actor is what we call the client. And the client is a person or really a machine, right? A machine that is making a request for some data or some information to another machine, which typically, at any time one machine is making a request to another machine, the machine that's making the request is called a client, and the machine that's receiving the request and sending back a response is called a server, right? And you might be familiar with that term. How many of y'all, just show a thumbs, or you can drop it in the chat. How many of y'all are familiar with the word server, right? You've heard it before, like, oh, you need a server, or hey, that's on a server, or that server is down, right? The PlayStation server is making me suck at FIFA, whatever it is that, wherever you heard that from. I'm sure you've heard of a server before, but maybe you haven't heard of a client, right? But those 2 parties make up the processes that take place on the web. You and your machine right now, as you're receiving information from my machine, streaming and all of this stuff, right, are acting as a client. You're asking for some information as I'm streaming and getting that information back to you, right? While I am also streaming, I'm sending this information up to Zoom and to YouTube and whatnot. And those 2 companies have massive amounts of servers like this one you see here in this image. And one of those servers actually contains the information from my machine that now you're getting back as a response, right? So this is the way that we're actually transferring data day to day, second by second, millisecond by millisecond online, right? One computer is acting like a client and saying, "Hey, I want to request some information," and the other machines are acting as servers and sending back that information that someone else requested. Requests and responses are both data objects. They're just objects of data being sent to and from different computers. Both of them have specific methods and specific properties to them that you can use to evaluate all of the information in a request or in a response. But the big fact is that, hey, I send some data as a client to a server. The server responds with some data to me as a client. And that's the process. That is the transfer protocol. You can see it kind of happens in this little loop of like one machine sends a request to another, the other sends back a response, and it kind of keeps happening in this loop. And this is the way that data is being communicated over the web. Now, with that, right, like I mentioned, there's a couple of different ways that we can get data from as a client. There's a couple of different ways we can request data from a server, right? Here are the four 4 to 5 methods that we can use, right? There's a get method, which allows for us to get some data or read some data from a server. There's a post method that allows us to insert data or send data to a server to add to do something with. Put and patch is typically used when we're updating or inserting data into and just like kind of more like editing or updating data more than it is directly inserting. And then delete would be like us sending a request to delete some data. Now, all of these are just general methods that were created to allow for us to transfer data from client to server. But the two most important ones that are used most frequently are these first two, the get method and the post method, which allow for us to read data and insert data. Sometimes you'll see people accomplish things like a delete request just using one of these two things. So of course, it's nice to know that there are these 5 particular methods that exist, but a lot of what you're going to see and encounter as you're looking at HTTP in real life is a lot of get methods and post methods being called. Again, this is all about like how we request information from a server. This will make a lot more sense as we start building out, or you start building out your own servers and understanding, hey, I'm going to have to be listening for clients that are asking to get some data or asking to post some data, and I need my server to process those requests. These are what servers are responsible for defining and processing from a client's perspective. The server, when it does that, will respond back to the client with a status. A status of 200 would mean that the request and the response and the request was successful and it got back some data successfully. 300 is typically when when you go to a link or you request some data and it sends you to a different page, right? Sometimes it will send back a 300 level status code. 400 level status codes, you might be familiar with like a 404 error, for instance, like when you're like page not found or stuff like that, right? Those are client errors, which mean that the person making the request, there was an error on their side. 500 level statuses are typically when the server encounters an error and there's a bit of, if you ever have had the experience of like one of your favorite sites being down, for instance, and it's like, oh my gosh, Crunchyroll is down, right? One of the reasons that happens is server errors, right? Some function, threw an error and it broke the server, and then they had to the server went down, right? When we say a site is down, typically it's because of a server error. But sometimes you might not be able to reach a site because your internet's not connected. That would be a 400 level error. Or sometimes you typed in the wrong name to a particular page. That would also be a 400 level error. Redirects, like I said, is when the site sends you to a different site. But anything else that's just a successful response is typically a 200 level status. That's what those are meaning. And so I bring this up because these are the operations that happen in this cycle of request and response, right? we ask for specific types of data from a server. The server gives us specific data and a status to go along with it to let us know if it was successful or not. And these processes make up our experience sending and transmitting data on the web. Now, what does this mean, and what does this mean for you, right? Well, this is where this gets interesting. Clearly, like I told y'all here, there's two parties in the HTTP process and in the web. When we talk about the web, there's always going to be these two actors, a client and a server, right? So that puts us in this position where, as web developers, we need to be familiar with things like the client side operations and the server side operations of the web, right? So most applications that we're building are going to involve us thinking about the client side part of our application, which is the side of the party that might be requesting some data, as well as the server side part of our application, which would be handling all of the actions that this client is requesting or asking for, right? This is where we get these terms like client side or server side. How many of y'all are familiar with those terms? You heard somebody say, like, oh, I like to be on the client side, or I like working on the server side, right? In the chat, you can drop which side y'all on. You know what I mean? This is like this ain't game stuff. This is just full stack development. Are you client side or you server side? You know what I'm saying? Or you on every side, right? That's kind of crazy. Anyway, client side, let's break that down a little bit more, right? Client side would be any part of an application that would take place on the end user's computer, the computer that is the one making the request, like we just talked about, right? Client side, just by nature of what part of the stack it's on, is typically where front-end development takes place, because front-end development refers to the things that a client of an application would be seeing, right? The client computer is the one receiving Google's homepage, right? So front-end developer teams would be working on the client-side experience of Google, right? Server side, on the other hand, is all of the actions that take place on the server machine, the machine that's listening for requests, right? Listening for these types of methods and responding with functions and these statuses, right? The server side teams have to work on those things, right? And the people who are typically working on server side stuff are typically calling themselves back-end developers, because they're focusing on the programming the clients don't see. These are the things happening on the back end, you know what I'm saying, that you only will know about if you're dealing with the server. If you're not dealing with the server and you're just getting the information back, you're on the client side and you might be more concerned with front end. Now, front end, back end, right? There are these separations when you look at the needs of programming teams. And if you think about a team like Google, Google's teams, which Google has many different products, many different projects, and very sophisticated technology on all of the fronts of their projects, right? They need multiple engineers on both parts of these applications, right? They need people on the front end and on the client side. They need people on the back end and then the server side, right? That's why there's all these different connotations of jobs. That's why sometimes you'll be like, oh, I see jobs for back-end developers. I see a job for a front-end developer, right? Hopefully now, and you let me know in the chat if this is true, hopefully now this makes a lot more sense, like what the difference is between client side, server side, front end, and back end. If that makes sense to you, drop it in the chat that it does. Send me a thumbs up, you know what I mean? Because this, I think, again, knowing the history, knowing the tools we're using because of that history, knowing how those tools work, gives us back to this perspective of what it is that we are going to be doing, right? And this is what it means to be a web developer, right? We're working on the client side experiences or working on server side experiences, front end and back end type of programming. Now, how does this relate to us and like the type of topics that we'll be talking about in this series of connections and dialogues? Well, a lot of us are here because we actually want to be full stack engineers, right? Now, this is what full stack engineers have to know is the stack on the client side and the stack on the server side. They need a stack to handle client operations and showing, requesting information in a user-friendly way. And um, they need to understand server-side stacks, technology stacks, and the types of programming languages and libraries that are useful in allowing us to create servers and respond to requests from clients from the server. Now, there's many different things your server might be responsible for, especially nowadays, right? Where we have AI being brought into the mix, or we have, the blockchain and like all of these other really interesting tools that we can connect to via server side programming, right? But just like we have a lot of developments on the server side, we're having just as much development on client side experiences and how to make websites more user friendly and intuitive. And now we're having whole new realms of client side experiences taking place on things like AR applications and VR applications, right? These are all connected still to these fundamental premises of how the data is going to be transferred from one place to another. And hopefully that makes a lot more sense to y'all now. But if you're like me, you want to know all of these things, right? Or at least enough about each of them to be able to consider yourself competent. And that's what being a full stack engineer is about, right? To be a modern full stack developer, sometimes you hear it being called a full stack engineer, sometimes you hear it being called full stack web developer, right? Um, you need to be familiar with the front end stack as well as the back end stack, the client side stack as well as the server side stack. And on the client side, like I was describing earlier, right? HTML and CSS are the ways that we create user interfaces on the web, right? That's it. We use HTML and CSS to structure web pages. Any web page that you go to online, whether it's Google's, whether it's TikTok's, whether it's New York Times, whether it's Chase, whoever's website it is that you want to go to, right? You're going to be taking a look at their HTML and their CSS. Those are the two things that allow for us to visualize information on the web, thanks to the work that Sir Tim Berners-Lee put into structuring the hypertext transfer protocol in specific ways, right? And the hypertext markup language, HTML, was a way to do that, to structure that information you're sending through HTTP in visual ways for someone to then read or someone to then see a page of information with dynamic links, or URLs, like he called them. CSS, right? HTML allows for us to create the structure of these web pages. CSS allows for us, or cascading style sheets, is what allows for us to put styling to those particular web pages and structure them in ways that make the content present itself in unique ways, right? All websites use the same HTML to a degree, right? They have, at least I was gonna say, they have access to the same HTML elements. They also have access to the same CSS elements, but the positioning of CSS elements in relationship to the CSS, excuse me, the way in which different firms use CSS to position HTML elements on a web page is what makes design and branding and all of these things so unique across different web pages. You could go to two web pages and have a vastly different experience just because of CSS, while those two web pages are actually using the same HTML elements. And we're going to see a couple of examples of that in the near future. But HTML and CSS are our client side, are for our client side experiences and what create our front end of our applications. You also need to know, if you want to be a full stack engineer, you also need to know the programming language for the web, right? And the biggest one, the one that you need to know if you want to be in web development is JavaScript, right? There are other languages that you can use for, back-end programming, for instance. But JavaScript is the de facto web programming language because we can leverage JavaScript to allow for us to dynamically modify our HTML and our CSS on the front end. So JavaScript is both a part of the front end as well as part of the back end. So that's why it's such an important language to know, because we need it to do things for our web page as much as we need it to do things to help in the server creation experience and responding of data. And nowadays, there's many different front end and back end frameworks that you'll hear about, right? On the front end, one of the ones that is the most popular is React, right? And that's the one we're going to be talking a lot about because that's the one I use and a lot of other developers use it as well, right? React is a front end, React is a client side library that allows for you to build front end experiences in JavaScript, which basically means we're going to be using JavaScript to dynamically create the HTML and CSS that make up our web pages. That's what makes React such a great tool because you can just use JavaScript to define a lot of really interesting things. And it turns out that doing that makes your web page not only it doesn't not only does it allow for you to use JavaScript to make the HTML and the CSS. There were other libraries and languages frameworks that did that. It also just makes it so that you can define the structure of these web pages in ways that are declarative and can can be very descriptive and allow for data to determine what shows up versus implicit data defined all at once, which again, that's just another topic we'll talk about when we get into React a little bit deeper. But just know that JavaScript is so important because of this. On the back end, Node.js is one of the most popular backend frameworks that you'll see people use in the full stack environment. There are other ones like I added Django here and for all my Python people, right? Flask, right? There's like other like backend specific frameworks that you can use in other languages, Spring, right? And Spring Boot for folks in Java, right? We can use other languages to do things for the back end of our application. But again, um, there is a great one of the things that makes JavaScript so ubiquitous is the fact that you need JavaScript on the front end, but you can use JavaScript on the back end as well. And so a lot of teams will actually build their entire stack around JavaScript because of that fact. Um, but knowing to go back a bit, right? Knowing this process of clients and servers and the differences between those two experiences and then knowing the languages and the frameworks that allow for you to structure those client side and server side experiences, that is what you will be doing as a full stack developer. So with that being said, I am curious for y'all, right? With that being said, what part of the stack are you curious about? Are you curious about the front end side stack of the stack, the back end? Or are you just full stack? You're like, hey, I'm still curious about all of this, right? I'm curious now for y'all. Sorry to say curious so many times, but I'm interested now from y'all's perspective, based on now knowing all of this information and history, right? What part of the stack is appealing to you? And to make sure that I can also respond to some of y'all's comments and things like that, I'm going to go ahead and just go back to stop sharing for a second so I can take a look at some of what y'all are talking about. Both, yeah, right. So, oh, I'm sorry. So it looks like when I stop sharing, it stopped my live stream. So I'm gonna have to just jump, let that go back up. But both, right? Yeah, back end, both. Okay, cool, right? All of them, right? Here's on the back end, right? Okay, yeah, that's what's up, right? There's a lot of different things going on there. And now I'm seeing a lot of some of the other comments and stuff that y'all are talking about, right? The full stack includes all of these different pieces that allow for us to make these connections. Now, unfortunately, like I said, the stream kind of stopped, but I will probably relaunch it. There was really one last thing I was going to show y'all, which is just a funny thing, and I'll just actually what I'll do is I'll just put the link to it in the Slack. But for those of y'all who are here still, I just want to show it to you. I want you to see the first website, right? Now that we talked about full stack engineering and all of this stuff, right? Are y'all curious? Like, would y'all like to see like what the first website actually looked like? Give me a thumbs up. You want to see the first ever website ever created? You want to see it? I'll show it to you. All right, cool. So here's the first website ever created. It's kind of funny because y'all are gonna be like, no way. That is cap. And I'm gonna be like, yes, Wade. That is it. Um, Let me start this. Share my screen one more time. So I wanted to show you this. Here it is, right here, right? This is the first ever website created. Welcome to the World Wide Web. And now for y'all, right? How many of y'all have actually seen websites that look like this, right? Just not necessarily like the content on side of it, but just the look
Professor, we are
of
not
it.
seeing the screen.
You don't see it? Oh, dang,
Nah.
man. Oh, dang, man. That's my bad. My bad. Let's see. It says it's sharing here. Let me try again. Yeah, Zoom is tweaking on me. I'm sorry, y'all. It's just, it's just another day. Let's see. Okay, it says it's sharing now. Can y'all see it now?
Yeah.
Yeah, no. Okay, cool. This is the website. Like I said, y'all was it's kind of mid. I ain't gonna hold you. But what I was asking is how many of y'all have actually seen websites that look like this before, right? Many of us, right? Because this is basic HTML, right? At its core, HTML just lets us structure text and structure hyperlinks to different information on a particular website, right? In our case, right? One of the things that's really fascinating about HTML, and we're going to talk a lot more about HTML next week, is that HTML was created to make it so that a page like this could show up on the web, right? So Sir Tim Berners-Lee had to create these things called hypermedia and hypertext, and hypertext is really the basis of HTML, right? And so here's a list of the terms that they created in this project. Anchors, which are these little links that allow for us to send information, right? Another one that you might be interested in is a browser, right? A browser is a program which allows a person to read hypertext. This is the history, y'all. You know what I'm saying? I just get so geeked about all this stuff. I'm like, dang, we really using a browser right now to interact, right? Buttons and cards, database, you know what I'm saying? Like, um, so these are very interesting. The domain, right? Um, just really interesting to me how all of this project work turned into the work that we do day to day as engineers in the full stack. So, like I said, I'll send over the link to this. There's actually a really cool. There's actually a really cool. This is Sir Tim Berners-Lee for those of y'all who are curious about him. Right, this page actually gives you more of the history of the web. It talks through the first web page and the first browser, right? A lot of really cool things to know if you're really interested in full stack stuff. So I'm gonna send this in the Slack just so that everybody can get a sense of, or just see it as a resource. Cause I think it's actually pretty fascinating. But yeah, y'all, that was really it for me. I really wanted to accomplish those big things um, with relationship to giving you the information about what does it mean to be a full stack engineer, and hopefully through that guided little lesson you understand it a bit more. There's a client side, there's a server side, and you and me will be talking about both of those different groups of programming duties. And I think it's really fun being a full stack developer because of the fact that you get this experience with this whole tool that we use on the daily. Um, so yeah, fam, I don't like belaboring points or keeping y'all longer than I need to. So that's really it for me. Again, you already know what your marching orders are. Do the HTML and CSS modules of the Codecademy. And I'll drop this link in the link to the video once it finishes on the YouTube stream, as well as the link to this little site talking about the first site on the web and stuff over for y'all who want to look at that. And yeah, we have class next week. I'm excited to see y'all again. And if you continue to stick with the class, I know this is semester. This is first week of the semester. So if your kids still interested, I'll see y'all next week. If you have questions, feel free to stick around and ask that. Otherwise, I'll talk to everybody else a little later.
Thank you, Professor.
No problem, brother. Take care.
Hi, Professor.
Take care, fam.
Hello.
Yo,
Yeah, I'd like to speak with you a couple of minutes.
okay, no problem, bro. Take care, fam.
I want to speak personally.
Okay, yeah, just wait around, then, brother. Take care, fam. Good night. Good night. Good night, homies. I know that Ben Hood wants to talk personally, but anybody else got questions that I can answer before y'all have to start?
It's okay, Professor. I don't know. This is only general question. So,
Go ahead.
for this for spring semester, I'm taking both mobile programming and the full stack web development.
Yeah.
So, which course have more job opportunity? So I can.
Yeesh.
Uh,
That's a good question. So you can figure out which one to stick with.
mhm.
Yeah. Um, man, that's a good question. I'll put it to you like this, right?
Mhm.
Mobile applications, like give me an example
Okay.
of a mobile application that you use.
I'm sorry. Can I listen to this too?
Yeah, yeah, go ahead. Ben Hur, give me an example of like a mobile app that you like that you use every day.
YouTube.
YouTube. Okay, cool. YouTube is a mobile app. We go on it on our phone. Now, here's a question for you. Does YouTube also have a website?
Yeah.
Yeah, right. So, and for the most part, YouTube as a site is also an app. We still use it as a web application. So it's not just it's not just like I go and read something. I'm like watching videos, clicking things, liking, comments, doing all types of really complex actions. So we call those types of websites web applications. So YouTube is an example of something that is both a mobile app as well as a web application, right? So the way I like to think about it is for most successful mobile applications, there's going to be a corresponding web application for that particular service, right? But not every service is a mobile application, but most companies have a website. You see what I mean? So if you look at it in the volume of that, right, there's probably more websites and web applications that need to be built than there are mobile applications to be built. But that doesn't mean that you can't get a good job in either of those industries because again, apps that are successful mobile apps also tend to have a web component to them too, right? But I'd like to think that like web has more opportunity. There's more opportunities for a company to build something in the web than there is in mobile, if that makes sense. Um, I was a mobile dev before I was learning full stack stuff. I found there were pretty good job opportunities in both. Um, But now I think it's just a matter of if you think about it, there's more companies that will need a website tomorrow than a mobile app tomorrow, even though mobile apps are a big means of how people communicate um, with things in general. So that's how I look at it, fam. I mean, it's really, I don't think you can go wrong. I've had folks in my class that also were taking mobile programming languages, and just from experience, I think a lot of them ended up doing full stack stuff work wise. So not to say that that means that the class is not teaching the stuff that, you know, mobile class isn't teaching the stuff you need, but that was just the experience of some of those students. Does that answer your question?
Yes, yes. Also, once I finish this full stack web development, I can apply for a job, right?
Yeah, yeah. How I would do it, I would be applying for a job and use the stuff you're learning now. To honestly, like the best way to go about it is these are skills that you're going to need to know to help different businesses with websites and stuff. So I try to tell this to people every semester, but I mean, if you walk to the bodega and ask them if they got a website and they say no, you know what I'm saying? Like, there you go. You know what I mean? You can make a job for yourself with this skill. But again, to answer your first question, if you went to your bodega and you're like, y'all want a mobile app? Most times they'll be like, you know, I don't think we need a mobile app. But do y'all need a website? You know what I'm saying? A lot more people are open to that idea, right? But you are learning skills that can help a business just in your neighborhood or in your community as well as a big company. So, I mean, I would use the skills you learn in this class to build cool projects that show that you can work on things for people. And then, yeah, you definitely can apply to jobs and try to get a job. But I think no matter what stack you learn, mobile or full stack, web stuff, doesn't matter. People, when you apply to jobs, are going to look for like, well, show me some of the things you've done so far, right? And so that's why you want to create projects that show off what you're doing a bit more. So, and that's one other reason why I like the web. The web is free, right? For an app to put an app on the app store, you got to pay Apple or pay, you know what I'm saying? Like, there's a lot that goes into putting a mobile app in the store, which deters a lot of people from making them, right? So the web is free. You can put projects up very easily, but if you were trying to put projects up online on the app store, it's kind of hard because of how much time it takes, and then you got to pay to have your apps in the app store. So to answer your first question again, I think that it's easier to make web projects than it is mobile projects. And then, like I said before, a lot of companies need people with websites, web-based skills to support them. And that, I think, just makes the market a little bit easier to get into. There's a lot more competition because a lot more people can learn web, and mobile you can find, you know, it's like, but with anything, there's going to be competition. But that's why you want to go the route of making projects that really show who you are and what you're capable of, even if it is some mobile, some web stuff, some Java stuff, whatever it is. And then you'll be in a better position to apply. But the projects that we're going to work on in this class will be great projects to show your competency in the full stack.
Oh, okay. So we're gonna build an individual project or group project?
Yeah, it's going to be individual. You have the opportunity to work on some of them with groups, but for the most part, they'll be individual so that you have a portfolio of stuff you can say you built.
Yeah, we can put them on the resume, right?
Yeah, exactly.
Okay. Very nice, Professor. So
No
thank you
problem,
so
bro.
much.
Thank you,
No
Professor.
problem. No problem, homie.
Good night.
All right, yo.